equals K1 times 1 over tau plus K2. So, P is blood pressure, tau is your PTT, and K1, K2 are parameters related to your personal conditions, like your arterial stiffness. So, we have to calibrate to get K1 and K2, and that's the most difficult part of PTT. So, so the K1 and the K2, is different. It differs by people and also differs over time because your arterial stiffness will change over time because of like aging and disease. So that means PTT requires calibration. So to get really accurate results with PTT, you have to do calibration. So there are different calibration methods. There's a person-specific calibration. That means you have to do this calibration very often to make sure your PTT parameters are accurate. Or you can use a population-based calibration. That means you input, like how old this person is, and what's the BMI of this person. Then from the basic information, we can get some parameters, but this tends to be less accurate. So in practice, we combine person-specific and population-based, calibrations to balance accuracy and convenience. But still, using the PTT method, you have to calibrate every few months. So that's the difficult part here. This is a device, a pair of device we used. We developed to use, PTT to measure blood pressure. It consists of two units. There's a chest unit. There's a limb unit. So the chest unit measures ECG and SCG, and the limb unit measures PPG. So, by using these two devices, you can get your PAT and PTT also. So some, data on this PTT method, you will see this plus. The x-axis is your PAT and PTT, and the y-axis is your like systolic pressure, mean pressure, and diastolic pressure. You see for the PAT, it has a pretty good correlation with systolic pressure, and PTT has pretty good correlation with diastolic pressure and mean pressure. This is really just one study, so there are many ongoing studies. And in these studies, this table surveys, different studies, and what they found here is that, the correlation between PTT and the gold standards are reasonably good, but not super good. Like it's about like 0.7 at best, so there's a lot of improvement needed for the PTT method, briefly speaking. But we do have an FDA cleared device. We do have an FDA cleared device for PAT measurement. So this this device also has two sensors, two units, one at the hand, the other at the chest. So think about this. So this is a PAT-based method. So what does the limb unit measure? What does the limb unit measure? PPG or
heart rate for SpO2.
Oh yeah, that includes SpO2. But in terms of PAT, pulse arrival time, it needs to know, how long it takes the pulse to travel from the heart to your finger. So for the finger unit or the hand unit, does it take PPG or it takes PPG? And for the chest unit, it measures ECG. It measures ECG. So it measures ECG. So this is how you get a PAT. Where is it? So for PAT, it's really the distance, the time between your R peak and the foot of your PPG. This is PAT. And for PTT is your aorta opening by mechanical acoustic sensing, and and then the foot of your PPG. That's PTT. So come back to this, yeah, because we are a little bit rushed. So, all right. So there's another method that you can use to measure blood pressure. This is based on pulse wave analysis, PWA. Essentially, in this method, we are looking at the PPG waveform. We are looking at the PPG waveform, so we can extract different features of PPG. like, we can extract a peak, and then there's a notch here, then there's a diastolic peak here. Then we also look at the first derivative to, find different features. Then we feed everything into a machine learning model. From there, we can get, systolic pressure and diastolic pressure. So just some emerging methods still under development. There's a lot of ongoing to make this method more reliable. All right, so the last section, it's not so, there's not so much information here. Let's just quickly go over this at a very high level. Dosimetry. So, we receive electromagnetic radiation all the time. So in particular, we worry about UV radiation. UV radiation is primarily driven by skin